So, what do you guys think of when I say trigonometry? What's the first thing you think of?
Triangle.
Triangles, good. Okay. So we have mainly been working with right angle triangles. Well, I guess only been working with right angle triangles when we think about trigonometry. All right, here's my right angle. And anyone remember what symbol we use for angles usually? What Greek letter we use?
Theta.
Theta, very good. Okay, angle theta. All right, now if you recall, the way I explained trigonometry to you guys was a bunch of old Greek dudes playing around with triangles in the sand, and they realized that if I draw a triangle of this size or a triangle of this size, like a smaller triangle, for example, this one, whoops, for example, this triangle, or if they made it a bit bigger, like this, right? If I made it a bit bigger and considered the same angle, but a bigger triangle, right? Because of what we know with geometry and similar triangles and shapes, the ratio of the sides in these triangles, they're all the same, right? If I divide this side by this side, it should be the same as dividing this side by this side, or this side by this side, etc., etc. And it goes for any of the two sides in the three-sided triangle. This side by that side, or this side divided by that side if it's a triangle like this, right? Three sides in a triangle, three ratios, all dependent on this angle theta. Okay, all depend on this angle theta. And they gave these three ratios a name, one each. Who remembers what those names are for the ratios? Who remembers what the names are for those ratios? Come on, guys, you can do it.
Sine, cosine, tangent.
Yes, good. Sine, cosine, and tangent. Okay, so we have sine of theta. So the angle goes inside. We have cosine of theta, and we have tangent of theta. All right. Now these are the fundamental trig ratios. All right. And what did we name the three sides in the triangle? If this was hypotenuse, good. So hypotenuse is here. It's always opposite the right angle. And remember, this is next to the angle. So what do we call something that's next to it? Such as an A.
Adjacent.
Yay, adjacent.
Adjacent.
Thank you, Martina. Adjacent, and this angle is on the other side. What do we call something on the other side of something?
Opposite.
Opposite, beautiful. Okay. And we sometimes call these shorthand H, O, A. All right. So the ratio for sine theta, written as sin theta on the calculator, was what? Which side divided by which side? Who remembers? Which side divided by?
Opposite by hypotenuse.
Very good, Shimon. Opposite divided by hypotenuse. Cosine was? Cosine was what?
Adjacent and hypotenuse.
Good. And then the last one, tangent or tan theta, was opposite over adjacent. Okay. So if this is my theta, sine would be this side divided by this side, O divided by H. Cos theta would be A divided by H. Tan theta would be O divided by A. Okay? And we had a little rhyme that helped us. Well, not a rhyme, but a shorthand. S, H, C, A. Exactly. Sokatoa. Okay, so just a little word, little nonsensical word that helps us remember the 3 trig ratios. So if you have a calculator and you write in your calculator sine of 35, for example, right? Your calculator has all these values because no matter
Wait,
Isn't that just 0.5?
no, sine 30 is
Dr. Lu, didn't you
Ah,
mix
yeah.
the SOHCAHTOA?
what's that?
Didn't you switch the O and the A at the end?
So thank you, Voita. I did. SOHCAHTOA. SOHCAHTOA. Okay. So your calculator has all these values, okay, for all the angles in a triangle, right? From 0, we can have a triangle like this, theta like that, we have a triangle like this, okay? But we've been limited to just regular right angle triangles for now, okay? So another example, if I do cos of, I don't know, just make up an angle, 27, you type into your calculator, you'll get a value. Okay, so your calculator knows all these ratios. Like I said, imagine a bunch of Greek dudes drawing a bunch of triangles, measuring the sides, dividing them. That's how we get these values out. We know exactly what each of these angles should yield in terms of these trigonometric ratios. Okay, so if I make up another angle, 10 to 65, putting the calculator up 2.145, okay, etc., etc. So that's regular right angle trig. Really quickly, in a nutshell. Okay, we use these values to help us calculate side lengths or vice versa. If you know the side lengths, we can calculate the angle. Okay. Whoops. So I need to go to that screen. Sorry. I pressed the wrong button.